Hello and welcome to buildingSMART webinar. This webinar is part of the buildingSMART Virtual Summit for Spring 2022. Thank you for joining. My name is Laura and I will be your moderator today. Today's webinar is titled Intelligent Creation of Construction Schedules, What-If Optimization, and 4D and 5D Analysis. Our speaker is Aleksandar Ilic from Bexel Consulting. This webinar is scheduled to last 1 hour with a short Q&A at the end. The webinar is being recorded and will be made available in the replay section of the event within 24 hours. Before I hand over to our speaker, I would like to remind you that your phone line will remain muted for the duration of this webinar. If you have any question or wish to make comments, please use the section-specific chat box in the control panel on the right-hand side of your screen. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Aleksandar.
Thank you, Laura. I'm going to just start sharing my screen now so everybody can see. Okay. Okay, we can start. Okay, good day, everyone. My name is Aleksandar Ilic. I'm a senior BIM manager and a product specialist at Bexel Consulting Company. And today I will present you intelligent creation of construction schedules, what-if optimizations, and 4D and 5D analysis. Even though the title is focused on intelligent scheduling, the presentation will also cover an integrated cost management process, and will try to explain how advanced computer algorithms allows for proper use of available BIM data and high levels of automation in project management. So what makes a difference between a simple 3D model and the BIM model is so-called information layer, or to be specific, an I within the BIM. So besides the geometry, BIM model contains an extensive data layer, and that data layer is a backbone of successful BIM implementation on the project. But as even this mem says, having the data or having a lot of data could be good, but could also pose problems. And having the data does not guarantee success. It is often the case that you have incomplete, inconsistent data that you just cannot use properly. In the first place, that is specific for a project-specific data that was not integrated or structured properly. Integrating such data often requires significant time, significant resources, and discipline. And if quality control process was not performed properly, you can end up with fragments of project data that could hardly be used for successful BIM implementation. On the other hand, almost every BIM model in the world contains a lot of reliable, standardized, well-structured information that is often overlooked, and yet it is very easily and very intuitively integrated in the BIM model itself. So let's say IFC properties, categories, families, buildings, stories, all of this information represent robust, reliable information that with the right tool could be utilized to serve as a basis for a good BIM analysis. Of course, in order to achieve this, it is of the highest importance to have an integrated approach to BIM. We have to be able to use and manage data from different sources, from different project phases and different BIM analysis. We have to be able to build new analysis and enrich project data layer by taking advantage of what is already integrated in previous phases and to minimize loss of information. So it is essential to have a system of integrated, interdependent BIM analysis relying on robust model data that could be enriched using knowledge bases. This integration and a sort of entanglement is something that is necessary for a successful BIM implementation, no matter if it is achieved through an integrated platform like Bexel Manager or through open BIM collaboration between different platforms. So in this process, the first step in this new approach then should be ability to enrich this existing robust data that we have in practically every model in the world. So how this works in our software solution. We have established a system in which user is able to predefine knowledge-based templates and to use the existing data. So let's say IFC classification data, categories, families, stories, buildings, all these system names, all this information that designers always intuitively integrate into their models without some specific requirement. And to based on this specific data that is more or less standardized, robust, and available in every model, user is able to enrich the model with additional layer of, let's say, classification system data, some data, some additional data regarding the properties of the model, regarding the rules of measurement, and all these layers that you need in the subsequent phases of the project, but based on this existing data. In order to achieve this in Bexel Manager, you can use an open API system, and user is practically able to specify its template to keep it in a, let's say, local computer disk or in the cloud. And whenever they start the new project, when they receive the new model, they can just download and import this specific rules for enriching the data and adding the new data and in this way classifying existing model elements into certain classification system. So you're able, so let's just give a simple example. If you know that certain elements are of the category wall, if you know that those elements are in a specific floors, if you know that those elements are structural or not structural, you are more or less able to define into which category in some standardized cost classification or project classification in general you can put them. And you can specify these rules and you can use these rules in all future projects without the need to specify to, let's say, designers to populate manually this classification data. So based on the intuitive information that is already in the model, you can do a lot of work. You can classify the model data, any model data, into classification system to a certain level. So here we're gonna see how this looks like in practice in the model element. So in this model, we have just this robust, detailed information about the categories, families. We have information if the model elements are structural or not structural. We have information about system names for MEP elements and things like that. And we are trying to enrich, to add a new layer of information, new classification layer of information, and we try to classify all of these elements within the model according to, in this case, you're going to see multiple different classification systems by relying on existing data. So what we can do here, we can just, based on the category of the elements, system group name, information if it's a structural or not structural, story elevation in some cases, we can determine the position of this element in this case in, let's say, uniformat classification system, and add a new property automatically to these elements that will be the code for uniformat classification system, but in the same time in DIN 276 coding system and also a uniclass code. Of course, it's probably not going to be 100% accurate. It's not going to cover all possible scenarios, but let's say that more than 90% from our experience, more than 90% of the elements could be pretty well classified just relying on this information. You just need to, in your process of developing model, follow certain rules and say, okay, when you are defining the element wall, just build it from the category wall and not use some other specific category, let's say, and specify system names in the MEP and things like that, but things that are more or less standard across the world when it comes to development of BIM models. So in this process, you basically just open this template, this knowledge-based template, and the information is automatically enriched or added to model elements. So if you select model elements, you're going to see that based on the existing robust information that was present in the model, we were able to just, add the new layer of information, to add multiple coding systems to these elements, and to sort of organize data and enrich it to be useful in the future, in the next phases of the project. So in Aleksandar, of course, you also have ability to visualize this new layer of data or any data in general. So here you can see that, we already have these categories and families, and we can just organize and visualize this information in the model. But what we can also do is we can create a new, what we call custom breakdown system, and we're going to just use the newly added information, the newly added layer of data in our model, and we're going to just try to visualize this newly added information. So we're going to see that with this enrichment method, we were able to actually classify all model elements into a standardized classification system with ease, and we were just relying on the existing data that is already available within the model, so without the need to go and manually populate this data to every specific element. Computer algorithm was able to identify to which specific classification category every element goes, or majority of the elements, based on the information available in the model. So with this first step, we were able to reach a level where our model is ready for more advanced use of BIM functionalities on the following phases of the project. So next phase, where we can, I would say, utilize this information, is a cost management. So what we are able to do once we have populated this new layer of information completely automatically with a very small amount of fine-tuning, let's say, we can just use this information, take advantage of this information, of this newly added classification system, and create a cost classification based on this new layer of information. So we have enriched the information that was existing in the model, and now we're using this information to create a cost classification in this specific project. To do this, again, we need a proper software and a proper workflow to do this. So in Aleksandar, this could be done by generating what we call quantity takeoff, and what will represent a sort of work breakdown structure for our future cost classification. So we can just, sort elements by the, in this case, uniformat assembly code, make a hierarchy, headings, subheadings, and, groups of works. And then based on this work breakdown structure, create cost classification structure. During this creation process, and you're going to see it in the video how this works, you also have ability to define the coding system for this classification. You have ability, again, to use the knowledge templates for the, let's say, classification item naming system. So if you're using, in this case, Uniformat, you can have a very simple knowledge template in which you're going to have all Uniformat codes according to the standard, and all Uniformat descriptions. And when you are creating a cost classification from your model, whenever the software encounters a certain Uniformat code or any other code, he can just automatically connect it to the proper description and proper naming for that specific position in the classification system. In the same time, you also have ability to import or to I would say open, let's say from your computer or from the cloud, the rules of measurement knowledge template. That means that for every specific group of works in any classification system, you can predefine the rules of measurement. You can predefine the quantity formulas, you can predefine the units, you can predefine the type of the quantity, and all of these things, and maybe even resources if you have pretty detailed knowledge base. And then based on all of this, you have ability to generate BOQ, and to use this BOQ, of course, as a 5D backbone of your project by just populating the unit prices into this automatically created cost classification, and then basically just use it to manage the costs in your project in the future. So if we go to a practical example, the systems looks like this. So first of all, we have this populated uniformat codes in this specific example, but it could be any classification system in the world. It doesn't even have to be some standardized classification system approved by some specific organization. It could be also some customized classification system that is specific for one company, let's say, or for one market, or for one specific project. So we have this information populated in the model, and based on this information, we're just creating a work breakdown structure. So how we can do this? By using some simple functionalities of Excel Manager, where we can sort model elements, by this code that we have added. So on the first level, we're going to use just the first symbol of this coding system because it's uniformat. So it's going to be A, B, C, D, E, F. So this main groups of works. Then on the next level, we're going to use, as you can see, first three and then first 5 letters of this code, so that we can get a pretty nice hierarchy of this cost classification. And on the 4th level, we're going to use complete uniformat code, of course. And below the uniformat code, we're going to use family name. We're going to do this because in this way, within the same, in this specific example, within the same group of works, we can later differentiate different subgroups of works. So this could help us to sort of mimic a system of uniformat plus master format combination, where instead of master format, we can use family name, something that is present in every model and the world, to differentiate different activities within the same group of works, the same category of the uniformat in this case. Of course, in this work breakdown structure, you also have ability to add quantities, multiple quantities for different categories of this classification system. And of course, again, you are able to visualize this work breakdown structure through the 3D color coded view, where you have ability to color code and to visualize different groups of works, different classification categories, and to check if it's properly distributed across the model. And then after that, you can just go to the cost editor, create a new classification, a sort of empty classification to say, and use this as the basis for automated generation of the cost classification. So using Creation Wizard, you are going to be able to use this specific form. So in this specific form, you just specify the work breakdown structure defined in a form of quantity takeoff that will be a sort of framework or basis for your future cost classification. So you just select this work breakdown structure. That means that he's going to now sort and distribute the elements according to these sorting rules that you defined in the quantity takeoff. So based on the enriched classification code, he's going to just group them in the subgroups of, in this case, uniformat classification system. Then you have ability to define coding system for the classification items. That means that you can, in this case, define this assembly code as the basis for the coding in your cost classification. So your cost and classification items will be coded according to this property again. So we utilize the information that was populated during the data enrichment process. Then you can separately define the coding method for the cost items. Remember that on the last level, we were using only family name as the convention to differentiate different activities within the same group of works within the uniformed classification. And for this specific activities, we can define the way how they're going to be coded. So they're going to use the uniformed code from their parent level, but then we can define this addition to this code, this substring that will be added. So let's say we can define it's going to be a uniformed code of the parent classification group, and then 0.001, 0.002, let's say, as one example, for the coding of the specific activities within these groups of works. So we can just define that. We can define a classification item name, and we can just again use a knowledge template in which we have specified, in this case, how different classification groups within, in this case, uniformed, are named. What is description and name for the specific groups in the classification. So he's going to automatically populate this information within the newly created cost classification. For the cost item name, we can use the information from the work breakdown structure, since it's a family name, it's something unique, and we don't have some specific standardized coding system for that, so we can just reuse the information that is available in the model. And the last part allows you to define rules of measurement. So sorry, I just skipped this video. Yeah, I'm sorry for this. Okay, so in the last part, you have ability to define the rules of measurement, that means that you have ability to define what will be the rules for calculating the quantities for every cost item. That could be some quantity from the quantity takeoff from the VBS, or it could be from template again. So how it works, you can have just a simple Excel template in which you define that all the cost items within a certain group of works, let's say the uniformed D 30, 40, 100, should be calculated in this way, let's say in pieces, let's say. So some other will be calculated by length in meters, some others will be calculated in area or volume. And not only that, you also have ability, let's say, for the group of works that is dedicated to, let's say, structural slabs in this case, you can predefine to the algorithm to introduce sub-activities for these specific groups of works, because those are, let's say, concrete elements. And in this case, he's going to automatically add the subgroups of works for reinforcement, formworks, concrete pouring, and concrete finishing, and automatically add the rules of measurements for these sub-activities. So once you just import this knowledge base that you keep somewhere in the cloud or in your computer, you are ready to generate cost classification. And if you look at it, it is a complete cost classification with a pretty clear hierarchy, which was completely extracted from the code that you populated at the beginning using an add-in. You also have all the names and descriptions that were introduced from this knowledge base, from this simple Excel file that says, okay, whenever you encounter certain code, just add this description. You have these sub-activities populated automatically for the specific groups of works that require them. And on the last level, you have the family names that will, differentiate different activities. You have proper rules of measurement defined, and you have also ability to export this cost classification to Excel to even further fine-tune all of this information. You can fine-tune it in terms of some descriptions, in terms of some quantity formulas that you want to little bit fine-tune and customize, to add resources. And the most important of all, you have ability to quickly and easily populate the unit prices, let's say, and you can even define them by material, labor, equipment, a subcontractor or some other type of costs. So you have ability, like in this case, to populate just the unit prices in this Excel, import it back to Excel Manager, and basically with this import, what you were able to do, you were able to just add another layer of information, to add the prices into cost classification that was automatically created from the information within the model and from the information available in your knowledge templates. So now you can just assign this cost classification to the model elements and get a project budget, basically. So based on these rules in the cost classification that were again automatically created, the algorithm will just find all the elements within the model that are corresponding to these rules. He's going to, based on the rules of measurement that you have defined in your knowledge template, he's going to calculate the quantities, multiply the quantities with the unit cost that was again added by the user in the Excel and imported, and will give you a complete budget organized and sorted according to a classification system of your choice. So the point is that we have started with the model without any dedicated data system that would allow you to introduce 5D management on this project in general. And with a few intelligent tools and with the good knowledge base, we were able to overcome these obstacles, to first add the new layer of information to existing information that is a classification information, and then to utilize that information to create a cost classification system, to assign it to the model and get the project budget. So once we have done this, the next step in the next, intuitive natural step in implementing BIM on the project would definitely be trying to add the fourth dimension, to add the time and to define the schedule in this model, in this project. So in order to do this with the Excel Manager, we again have ability to exploit the information that was already populated in the model. So this cost information, classification information that was added could be utilized to create the schedules as well. And not only that, using this information, you can automate this process, and you can make it more precise, more reliable, and much less time consuming. So how it is done? It is done through the intelligent scheduling engine, in which you are creating the schedule logic instead of schedule itself. And then with this schedule logic, a computer algorithm generates the schedule structure for you. So what you're doing, you're defining what we call zones and methodologies. You as a user just define these levels of project organization, combine them into a creation template, and based on this template, the computer just auto-generates the schedule with all the tasks and all the relationships. And then you are able to fine-tune this schedule, to create multiple versions of this schedule, to use it in the future for progress tracking, to report KPIs, payment certificates from these schedules, and to create automated 4D and 5D simulations. So I will try to briefly explain how this whole system works. So the intelligent scheduling is relying on the basis of traditional scheduling or planning process. So if you think about the scheduling in general, and you all probably have experience in developing construction schedules, in every scheduling process in the world, in every project in the world, you are doing the same two processes. The first one is spatial project organization or spatial distribution of works. So let's just simplify it. If you try to create a schedule in, let's say, MS Project, the first thing you're going to do, you're going to just define the parent tasks for every building, the parent tasks for every phase, and the parent tasks for every floor in your project. So what you're going to do, you're going to mimic spatial organization of your project on site. You're going to first try to define these spatial categories within your schedule. And then when you do this, the next level is defining work sequence, or that we call methodology. That means that within all of these spatial categories, spatial zones that you have defined in your schedule, you're going to define over and over from the beginning work sequence. That means that you're going to say, okay, first I'm going to have foundation works, then slab on grade, then concrete columns and walls, then concrete beams and slabs. Just one short part of the work sequence on any typical project in the world. But the problem is that in a traditional scheduling process, you have to go to every single spatial part of your schedule and to define this sequence, over and over again. And on every new project, you have to define it over and over again. And if you think about it, this sequence is pretty intuitive, and it's pretty easy to explain and pretty easy to understand by any engineer in the world. The only problem is that the tools does not allow us to do this in a more intelligent way. So our approach is a little bit different. So what we tried to do, we tried to organize planning process in this way, that planner is only defining the levels of project organization. That means that you are defining the relationships between buildings, the relationships between floors, relationships between zones, and relationships between different groups of works. And then you just combine them into intelligent template, which then defines specific tasks in this schedule and specific relationships. To simplify it, instead of going and creating, let's say, formwork for the concrete columns on the first floor in this phase 1 in building 1 and repeating that process for the second floor, for phase 2, for phase 3, for building 2, you're going to just define that the sequence of work is slab on grade, then concrete columns, and the software will create the tasks on every spatial zone, on every spatial part of your project by itself, and will transfer this relationship between these two groups of works to all of these different levels of schedule. With this in mind, you are then able to very easily create schedules of a big scale in the first place, to create schedules and to transfer this logic, this work sequence from project to project. And how this is possible? Well, it is possible because this work sequence, this methodology, is based on the 5D data, on the cost classification. So instead of you going and manually selecting the elements that represent foundation, and then manually select the elements that represent slab on grade, and defining the relationship between these two tasks that are manually connected to the groups of elements, you are just defining a relationship between classification categories that are related to the foundations, classification categories that are related to slab on grade. And then if this is the case, on every future project, you're able to use the same logic and the same methodology. So after you define as a user all of these levels of organization, you just combine them in what we call a creation template, and then the software itself just goes through these organizational levels that user was able to define, and creates the schedule structure itself. So all the tasks and all the relationships by itself. And if you see in this specific case, we have defined the relationships between buildings 1 and building 2. We have defined the relationships between main groups of works, so the work sequence. We have defined the relationships between subgroups of work. So within, let's say, structural columns, we have defined that we have 4 sub-activities for formwork, reinforcement, concrete pouring, and concrete finishing. We have defined the sequence of floors, that they're going to be from the lowest floor to the highest. And we have defined that on every floor, we're going to work in 3 separate zones or phases. So this is all the levels of schedule that we have defined. And the schedule itself will be created as a combination of all of these rules, where for every combination available, a software will create a task and will create relationship between the tasks. So again, to simplify it, in building 1, building 2, on every floor, in every phase, you're going to have a task for structural columns, and subtasks for the formwork. And you're going to have all the relationships from these methodologies and logic. Why is this also important? It is important that if we go to the next use case where we have the same type of the project, the same type of structure, so it's a reinforced concrete structure, but we have project of much larger scale with a different spatial distribution. So instead of 2 buildings, we have 20 buildings. We have two big sectors, but we have the same cost classification, and we have the same technology of execution, and we have the same logic and work sequence. So what we're going to do, we're going to just transfer the work sequence from the previous project, the methodology, which is the most complex part of the scheduling, and just create a new spatial distribution. And instead of building 1 and building 2, define the relationships between 20 buildings. And then with this smart software, we're going to be able to reuse this methodology and to scale up the schedule. So with this almost the same effort, we're going to create schedule that is 20 times bigger. So that's the whole point, that you once define the methodology, the sequence of work, something that is standardized, something that is tied to your classification system. After that, you just transfer it to the next project. And on the next project, you're just changing the spatial organization of your schedule because you have projects of a different scale. Of course, you're not going to have the same methodology for the steel structure and reinforced concrete structure, but between two reinforced concrete structures, you can reuse these methodologies. This could be also applied for the infrastructure as well with ease. The only difference is that, of course, methodology will be a little bit different, but it's going to be, again, interchangeable between two infrastructure projects of the same type, 2 viaducts, 2 tunnels, 2 roads, or 2 rails. The only difference will be that instead of having this 2 levels of spatial organization, vertical and horizontal, in this case, you're going to have just horizontal spatial organization, or to be more precise, linear project organization. So you're going to have axis, and you're going to have chainage. So you're going to have small steps on this axis of executing the works instead of buildings and levels and zones. This is also one of the real use cases where we were able to implement the same logic to a FIFA stadium project, so a large-scale project, very complex, with a lot of different groups of works, and it enabled us to create a schedule of more than 100,000 relationships and tasks for one single project, because we were just able to organize the schedule on the main schedule organizational levels instead of creating every task and every relationship manually. And as a product of this process, at the end, the user gets the simple schedule structure. Why I say schedule structure? Because duration of all the tasks is equal. So what user has to do, but there's no problem because the schedule structure is completely customizable. So the user can change everything in this newly added schedule structure. It can just change and optimize durations, change and fine-tune the relationships. The great thing is that you can also switch between line of balance view and Gantt chart view for the same schedule. So you can also optimize it regarding the line of balance and flow line. You have, since we were using the cost classification as the basis for our rules, we have automatically integrated this newly created schedule with the model elements. We have integrated it with all information in cost classification. That means for every task in the schedule, you have right away information which groups of works and which activities are part of this task, what are the resources assigned to these tasks, what is the price of this task, and you can see cash flow, you can see cumulative cost, you can see resources and activities right away available for your schedule. And with all this information, you can very easily assess the viability of your schedule and the quality of your schedule. So you can see, okay, if I have some really high required level of resources in a certain month, probably the tasks that are planned for that month are too short. I'm not going to be enough. I'm not going to have available resources for this, and then I'm going to be at risk. So I can just go and very easily stretch these tasks to make this schedule more realistic and more viable. And also right away you have, since everything is fully integrated with your BIM model through the cost classification, you have right away the construction simulation available. So you can check that as well. So this is a practical example how the whole process looks like. So if we talk about spatial organization of the project, again, we are relying on information that is available in the model. Every model has defined buildings, it has defined phases, and even if they are not defined, it's easy to define it within the user interface. Every model has defined the stories, so we can just rely upon that information, and we can, based on this, go and create the zones for this project. Of course, we also have this uniform coding system. We have cost classification, so we can, based on this, create the work sequence organization for our schedule. So how this looks in practice, within the what we call a zone editor, user is just creating the zone items and relating these zone items or nodes to the information in the model, to the information about the phase of the elements, about the building in which the elements are placed, about the floor on which the elements are placed. And all of this information are uh, uh, present in the model, by default. Every designer always puts this information into model. So you don't have to spend some incredible amount of time. You don't need some specific process and procedure to require designers to just place the spatial information to the model. That is something that they're going to do anyway. So you can rely on this information. And on the other hand, when it comes to methodology, what we are doing, we're creating the work sequence in this way. We're just creating, again, the nodes that are related to the cost classification that we have just created. So let's say we're going to just connect to the foundation piles, and say they're going to be executed first. After that, we're going to execute the foundation footings and pile caps, that's completely natural, intuitive workflow. Then we're going to go with the slab on grade, we're going to find the slabs. The next classification category in uniformat, we're going to be able to define relationships between them, the type of relationship, the lag if we need it, and so on. Of course, to do this for the whole project, it would take too much time for presentation. But this is how for this demo project, this is how the completed methodology looks like. So we have the nodes, and we have defined relationships between different groups of works, and those groups of works are related to the model elements. So based on this, we're going to just create what we call creation template. We're going to just combine these zones and methodologies into one single template. We're going to say, okay, first we want to organize model elements by buildings, then by the methodology that we have created. Then we're going to distribute the works on the levels, and then on every level we want to distribute it to the construction sequence, to the phases, let's say. And now we can just go to the schedule editor, create schedule that is connected to the cost version that we have just created, the cost classification. And we can just again use wizard. So in pretty same workflow as with the cost classification, we can just load the template that was created based on the spatial information of the model and based on the classification that we have created again from the work breakdown structure that was, on the other hand, based on the enriched classification codes that were again based on the knowledge template and existing robust information within this model. So you have seen how we, from the very small amount of data, but well-structured data, we were able to just enrich model to the point where we can just create complete schedule out of the information that is present in the model. So you're going to see that the schedule has like 1,500 tasks, 3,000 relationships, and all of this created automatically based on the knowledge or based on the templates that you have defined to the software. Of course, you can switch between a Gantt chart and a line of balance view. You have ability to check the animation of this schedule. So this schedule is right away connected to the cost classification, right away connected to the model elements, and you can see the animation of the schedule. So you can check the work sequence, if it's a proper work sequence, if it works as you intended to work. And the best thing of all is that all of these methodologies could be transferred to the next project of the similar type with the similar cost classification, and it's going to work. Of course, if it's not going to be a 30 floors building like in this case, maybe you're going to slightly change this methodology. Maybe you're not going to have these core walls going first before the rest of the structure, but those are minor changes and minor customizations for your methodology that could be reused in the future. What you can also do, you have ability to color code the tasks in your schedule. In the Gantt chart, you have ability to do the same thing in animation as well. So you can see the different codes for different activities in your schedule. You have ability to go back to the schedule animation and to again visualize this information very easily. So instead of having the textures on your model, you're going to have color-coded elements by the specific activity that is performed on that specific model elements. So another possibility is that you can also, in your schedule, go and visualize different properties of your tasks. So let's say you can color code your tasks in your schedule by, let's say, duration, by last entered date, by total float on every scheduled tasks, let's say. So you can see the different color coding for different values, and you can also visualize it in 3D in the cost class in the schedule animation. So you can visualize, let's say, if you have the actual schedule, you can visualize CPIs, SPIs. You can see which parts of the structure are, let's say, green with the good CPI, which are red with the bad CPI, and things like that. What you can also do is you can have your schedule animation also color coded with the custom breakdown system. So now you can color code it by uniformat, you can color code it by floors, you can color code it, let's say, by subcontractor, by different buildings. So any information present in the model could be visualized through this color coding system within the user interface of Baxter Manager, but also within the animation itself. You also have ability to color code the critical path tasks, both in the Gantt chart and in the tasks itself, in the task lists. You also have ability, since, as we said, this schedule is based on methodology. The methodology is based on the cost classification. That means that all the cost data from cost classification is right away available in the schedule. So if you go to the schedule, you have ability to check these statistics of the schedule. So again, the schedule could be further optimized and fine-tuned. Here is the same schedule with the optimized structure, with some durations are changed according to the needs of the project. Some activities are delayed. They are set as late as possible activities, some finishing activities, So we were able to fine-tune it and to get more optimal schedule structure. This was the original, so you're going to see the difference in line of balance, that optimized structure was much better, and it was done in barely 15 minutes to get the better results. So again, if we check the task report, if we check cash flow, cumulative cost, activities on this schedule that was just created, and compare it to the optimal schedule, to slightly optimized schedule, we're going to see that these statistics are much better. So basically, these statistics are checking points for the planner, where you just get the schedule structure, you just check the cash flow, you check the cumulative cost, you check the activities, you can check resources, and then change and optimize durations and fine-tune relationships so that you can achieve the best possible results with your schedules in the future. And not only that, all of this information, all of these animations, all of these selection sets, and even clashes and everything that is available within the Bexel Manager could now be published online. So you're able, with a simple publish functionality, to just publish all of these things into a Bexel viewer, the new application that is a cloud-based application. So let's say that you want to publish selection set with the elements that should be executed next week. You have that information from your schedule, from your animation. You can just publish that to an online viewer, send someone a simple link that person, let's say on construction site, can open it on the tablet, on their phone, and could just open it in the browser and just see in 3D environment those elements that should be executed. It has ability to select those elements, the elements that are, let's say, are really executed, the actual progress on site, and return you back a BCF with this information, which you can integrate in the office, in the official schedule for the project. You can also send the animations. You can also send the clashes that could be visible in this online viewer as well. And these are just a few short video sequences how this whole process works. So basically, within the Bexel Manager environment, you have a new functionality that is called Publish to Viewer. You just get the viewer link, open it in the browser, and then send it to anyone. That person can just see the selection sets that were sent within the model, visualize it, turn off, turn on the elements. It has even ability to section the model with ease within the viewer itself. To select the elements, it has ability to select color code elements, to add notes to these elements, the annotations, and let's say progress monitoring, and give a description to these specific elements, and to send it back to you via OpenBIM BCF format. So we can just add an annotation, color code the elements, and save a BCF and send it to you. You're also able to publish animations, color coded animations, to show different parts of the building, how they're going to be built, what is the work sequence, and you have ability to customize all of this. So right now with this new product, users are going to be able to communicate and collaborate easier with the other stakeholders in the project that are not using the Bexel Manager in this case, which is expert software, but you are going to be able to share parts of what is done in the BIM implementation on the project with other stakeholders. So let's say the cost data, the animation data, the look ahead plans. You're going to be able to receive actual executed elements that are just simply selected on a tablet by a person on construction site or multiple persons on construction site, and then integrate that information into schedule. That would be it for today. I want to thank you for your attention, and just to use this opportunity to invite you to the next presentation from our company tomorrow in the morning, where my colleague Mileta Pejovic will basically just continue this workflow. So today we were going through the process of enriching the model data, adding the new layer of classification information, creating the cost classification out of this classification codes, and creating schedules and optimizing the schedules based on this information. Tomorrow, my colleague will go through the process of progress tracking using all these workflows with the viewer. So it's going to be more detailed overview of the viewer and the functionalities of the viewer, and how all of this information that we have created for 4D and 5D could be utilized in the execution phase of the project for progress monitoring and reporting the main KPIs of the project.
Thank you, Aleksandar, for your presentation. We've got some questions.
Mm-hmm.
The first one is from Michael. He's asking, how do you deal with IFC building element parts, like a clouding layer of a wall?
Okay, so Are you gonna pick some questions for me, or we can go with the okay, you were referring to this first question. How do
Yeah.
you deal with okay, cladding layer of the wall? Well, yeah, if those are parts of some assembly, we have a workflow where we are able, with a simple API script, to add this information about the layers that are within the wall, and then to classify them as a separate items, as a separate families, basically. So the cladding could have the information to which assembly element it belongs, and we also keep these relationships between them. So you're going to be able to select the assembly and then to select the sublayers like cladding of this wall assembly, and then you can use them in the same way as with the with the specific families and specific elements that doesn't have the parts within it.
Thank you. We've got some discussion on the chat on that question from Avon. What about QTO, price of elements that don't have a 3D representation? An example is pen layer on a wall. This area is not always the same area on the wall surface.
Okay, very good question. Well, the point is that you can relate multiple cost items to a single element. So you can have multiple, let's say, multiple codes on the same element. On that wall element, you're going to have a code for building the wall, but you're going to also have a code for painting the wall. So you're going to just create a cost classification item that will just say, okay, find me the element that contain this code for painting. So the same element will be within the group of works for building the wall, let's say masonry wall, and also for group of work for painting the wall. So that's the way to do it. You don't have the 3D representation of these works, but you have the element on which you can apply that, because you know that this wall is going to be painted. You just add additional code for painting to this masonry wall, and it's going to work properly.
Thank you.
Yeah.
The next question is from Edgar.
Mm-hmm.
How did you deal with the chainage in linear project? Were there specific requirement mentioned in the BEP for you to pick up element in Vexel Manager, or did you have the model prior to importing?
Yes. Well, yeah. When it comes to the chainage in linear project, that's also a very good question. Is yes, in most cases, in the BEP, we require additional property that just defines the start chainage and end chainage of the element, and based on this later, we can always group them into bigger groups. So if those small elements could be grouped into steps of 50, 100, 150 meter steps, what is the most practical for the planner, to execute it. So yeah, for in these cases, you just need some additional property that will define the chainage. So of course, it's not as intuitive as with the high-rise buildings, because there people intuitively define the spatial organization of the project. They define the floors, they define the buildings. In the infrastructure, you need additional effort to define this chainage, but again, that's in most cases that's something that is standard thing, because even in preparation of the drawings, you need to have this information of the chainage, where this element is placed on this axis. So yeah, it is required in BEP.
Thank you. We've got another question from Edgar. Do you do any checking on the zones and floor? Often mistakes are in model where items are associated with the wrong floor or zone.
Yes, we have multiple functionalities for this. One of the possible is, first of all, you have seen that we can visualize this information. So you can color code the elements by, let's say, property story. So the first thing and the easiest way to see where these problems are, you're going to see that, I don't know, on the 5th floor, you have the red element, and the red is color coded for the 1st floor. So visually, you can see this. Of course, there's also a checklist where you can specify which elements should have which spatial information, and the computer algorithm, the checking algorithm, will just find all the elements that are not complying to these rules. In Vexel Manager, you also have ability to, let's say, this very good example with the elements that are placed on the wrong floors. You can select elements and say auto distribute. So in Bexel Manager, the software can just identify if the element is between these two elevations and place it in the right position automatically. So this could be done even without returning this model back to designer, but you as a project management manager could just add these changes to the model so that the spatial structure is proper.
Perfect.
Yeah.
The next question is from Yasin. Are you considering two types of spatial zone, vertical, which are story, and horizontal, in this case, buildings?
Yes, exactly like that. You consider two types of spatial zones. If we talk about high rise, if we talk about buildings, if we talk about linear infrastructure projects, then we're not going to have vertical ones. But from the functional point of view, there is no difference in the user interface or the way they are created. They're created in the same way, using the same functionalities. You just combine them in the template in a different way. But yeah, you basically have the two types of zones.
We've got a few more questions to go through, if it's okay. The next one is from Angio. Thank you for the presentation. So for the information is added using the viewer, and what is the interface for API then?
No, maybe you misunderstood. The information is not adding using viewer. It is added using API add-in. So basically, you just install a simple add-in, which is available for free in Bexel Manager. You have it in your ribbon, and just click. You have the small window user interface for importing that knowledge base template, and then you just import the template, and it works. And it basically populates the information into the model. So the user interface is basically organized through the add-in. So you just click the add-in, you get your user interface window for that add-in, and then just navigate to the template, knowledge template for the enrichment for the information, and then that information based from that template, Excel template, is automatically added to the model elements.
Thank you for a thorough answer. We'll just go through the last few.
Okay.
So the next one is from Michael. How do you deal with authoring tools that do not use families?
Well, in these cases, we are just referring to some other property, So let's say with infrastructure, that's often a case that everything is, I think I also saw one question about it. Everything is element proxy, IFC element, building element proxy. So you cannot differentiate, let's say, column or slab or something like that. But most authoring tools for infrastructure, or at least very developed one, add a new set of property. They give the name to this IFC element proxy, that will classify them. They give some additional property that will call the type or something like that, and then instead of family, we're going to use that property as well. So in most cases, we're going to have this information. Of course, if you get the model that is made only for a 3D representation, you're going to have a challenge, because if somebody just made something to look as realistic as possible, that's not the BIM model, then you don't have any property. But this workflow is not limited to the family name, so you can use any other property that will give you the proper information as well.
Great. This will be the last question. Okay. I believe Mileta just answered it as well on the chat. How do you deal with paint not going to the 100% of the wall surface?
Well, very easy. In the calculation rules for that wall, you're going to say, okay, I'm not going to use the area of that wall. I'm going to use length of that wall times the height of the wall to the level where I'm going to paint it. So you can always modify it. You're not limited to the properties in the model. You can use it in the form of formula. So you can have the form or say, okay, I don't know, maybe the 50% of the wall is covered. I'm going to say use the area of the wall, but then times 0.5, and that will be the quantity for the paint. So you're not limited with the property of that wall. You can always, with the formula, modify that property to give you the right information.
Thank you. Would you like to add anything before we close the session?
Well, I just want to thank you as organizers for this great opportunity to present my views and views of my company on BIM in general and project management in general. And I want to thank all the participants for very good questions. I'm really, really excited about these good questions that tells me that people really understand this approach. They understand how we imagine our software, and they're just asking the right questions. And I just hope that this was useful to everyone, and that in the future we can even cooperate.
Well, thank you, Aleksandar. Thank you, all the
You're welcome.
participants. I will be closing the session. Thank you very much for attending. Thank you.
Thank you all.
Bye.
Have a nice day.